Round. Literally. We're talking about those invisible forces that make things turn, twist, and rotate, from something as simple as a doorknob to the wheels on your bike.
And let's kick things off with a question that's right in front of you every single day, but maybe you've never really thought to ask. Why are door handles put way over there? I'll give you a hint. It has nothing to do with how it looks. It's all about a brilliant piece of everyday physics.
You know, every single time you swing a door open, you're actually demonstrating a fundamental concept. You're not just applying a force, a simple push or a pull. The real magic is in where you apply it.
So, to really wrap our heads around why that placement matters so much, we gotta start with the basic building block of all this motion, the idea of force itself.
All right, let's break this down. At its very core, a force is just a fancy word for a push or a pull. It can make things speed up, slow down, change direction. It can even change their shape. But for our explainer today, we are laser-focused on its amazing ability to make things rotate.
Now, here's where it gets really interesting. Just having a force isn't enough to guarantee a turn. Nope, it needs a partner in crime. Distance. And when force and distance team up, they create something pretty special.
And that special turning effect? Well, it's got a scientific name, the moment of force. But you'll probably hear it called by its much more common name, especially if you're into engineering, torque. Think of it as the spinning version of a straight-line force.
So, it all boils down to this super simple but incredibly powerful formula. The moment, which we write as m, is just the force you apply, F, multiplied by the perpendicular distance from the pivot point, which we call d.
So what this tells us is you've got two ways to get more turning power. You can either push or pull harder. That's just increasing the force. Or, and this is the clever part, you can apply that same force further away from the pivot. And that's why the door handle is way over on the edge as far as it can from the hinges.
You've actually played with this idea of balancing turning forces your whole life, probably without even realizing it. I mean, if you've ever been on a seesaw, you've basically been a human physics experiment, trying to figure out moments in real time.
And hey, this whole balancing act, it's not just for the playground. It's a fundamental rule in physics that explains how everything from massive bridges to a gymnast on a balance beam can stay perfectly stable.
This right here, this is called the principle of moments, and it is the absolute golden rule for keeping things perfectly balanced and stable. Basically, for an object to not spin out of control or topple over, all of the turning forces have to perfectly cancel each other out. A great way to picture it is like a spinning tug-of-war. You've got the clockwise moments trying to pull it one way and the counterclockwise moments trying to pull it the other way. When those two are perfectly matched, bam, you get perfect balance. That's what physicists call equilibrium.
Okay, so we've covered what happens when a single force makes something turn around a pivot. But what if you have two forces working together with no fixed pivot point at all?
Well, that's where this really neat thing called a couple comes in. It's a pair of forces that are equal in strength but pulling in opposite directions. And because they aren't pulling along the exact same line, they are fantastic at one thing, creating pure rotation.
So, here's what you gotta remember. For a couple, you need two forces, equal but opposite. They have to be acting along parallel lines. And when you have that, you get this beautiful, pure turning motion with no pushing or pulling the object forward or backward. You do this all the time, turning a steering wheel with both hands, using a key and a lock, winding up an old clock. You're applying a couple.
All right, so let's recap. We have two main ways to make things turn. A moment, which is from a single force, and a couple, which uses two forces. Let's put them side by side and really nail down the difference.
And there it is, the key difference right there. A moment needs a pivot point. It's one force acting around that pivot. A couple, on the other hand, doesn't need a fixed pivot because it has two forces creating that pure, clean spin all on their own.
Okay, so if you're ever faced with a problem and need to figure this stuff out, here's your 5-step cheat sheet. 1. Find the pivot. 2. Figure out your force in the distance. 3. Plug them into the formula, m equals F times d. 4. Check which way it's turning, clockwise or counterclockwise. And 5. If you're trying to balance something, just make the clockwise moments equal the counterclockwise ones. It's as simple as that.
All right, let's bring this all home. We started with a simple door handle. Let's end with a wrench. Based on everything we've just covered, can you see now why a wrench with a nice long handle makes it 100 times easier to loosen a super stubborn bolt? Yep, you got it.
As you now know, the answer is all about the torque.